Welcome to lesson 211. As you'll see, we're in unit 2 now. We're going to talk about ratios and proportions. Today's objectives: I will be able to create drawings that depict different ratios, use drawings to solve problems involving ratios, and use a table to solve problems involving ratios. So first we need to know what is a ratio. A ratio is a comparison of two different items, usually a part to a part, but sometimes it can be a comparison of a part to a whole. Right, so what we're talking about here is if I were to look at a class and look at the ratio of teachers to students. Teacher is a part of a class, students are a part of a class, so this would be a part-to-part ratio. And you can write ratios in three different ways. You can use the colon, you can write it in words using the word to, or you can write it as a fraction or in fraction form. But it is not a fraction. You have to remember that it's a ratio. So typically when you see ratios, you'll see them written with the colon. Right, so if you're also looking at a class and you look at the number of boys in class to the number of girls in class, that would be a part-to-part ratio. However, if you were looking at the number of boys to the total number of students in class, you're looking at a part because part of the class is made up of boys, and then you're looking at a whole because the class is one whole. Right, so we're going to take a look at this and we're going to write the ratio of stars to triangles. Now, writing ratios can be very simple, but it can be made very difficult if you're not paying attention to what they want you to write. So you first have to look at what they want first and then what they want second. And what they want first has to go first or it has to go on top. Right, so if they want stars to triangles, then you know that it should go stars first, colon triangles, or stars on top, triangles on bottom. So in this case, we're just going to count 1, 2, 3, 4, 5, 6 stars. 2, 1, 2, 3, 4 triangles. And again, this is writing it using the colon. You can write it using words, so we can say 6 to 4. And we can do it in fraction form, putting the 6 on top and the 4 on bottom. Now the biggest mistake students make is they take this and think it's an improper fraction and they like to change it to a mixed number. Remember, this is not a fraction, this is a ratio, and you do not change it to a mixed number. Right, so I'd like you to take a minute, take a look at the picture, and I'd like you to write the ratio of females in this group to males in the group. I'd like you to write it in the 3 different forms just so you get practice at it. When you come back, we'll go over your answer. All right, so in the group I have 1, 2, 3, 4 females, and I have 1, 2 males. So my ratio should be written like this if I used a colon. Or I can write 4 to 2. And as fraction form, I can write it as 4 over 2. Now you have to be careful because if you write it the other way around and you write 2 to 4, you're telling me that there's 2 females and 4 males. That's why it's important to remember what's listed first has to go first in your ratio. All right, so tables are a form of a ratio as well. So if we're looking at the number of teams and the number of players, so if there's 2 teams and 14 players, so this would actually be more of a whole to part type of ratio. Right, so we have 2 teams to 14 players. Now what I can do is I can look at this and say, all right, well if 2 teams have 14 players, then I'm just adding 7. Well, I would bet that 3 teams have 21 players. And this is also a form of finding not equivalent ratios, but using ratios to create new ratios. So whatever I do to the top, I have to do to the bottom type of thought when we talk about equivalent ratios. But since these are not equivalent ratios, we have to look at how the pattern is progressing. So we're using the pattern to figure out how many teams there are. And I know that this is a matter of dividing by 7 to go from bottom to top, or if I go from top to bottom, it's times 7. So to find the 3, I took 21 and divided it by 7, and I got 3. because I know that if I do 28 divided by 7, I get 4. So to find the number of teams here, I can do 35 divided by 7, and I get 5. Okay, again, this is not like finding equivalent fractions or ratios because they're not equivalent. You're using a pattern to find the next ratio. We'll talk about equivalent ratios in a different lesson. All right, so I want you to take a minute, I want you to pause, and I want you to find the pattern, and I want you to find the missing information here. So how many pizzas, and what's the cost, and then again, how many pizzas. And when you come back, we'll go over your answer. All right, so what I do is I first look at this problem right here, and I know that I have 4 pizzas at a cost of $20. So I can, yes, say that it's plus 16, but we know that when we're working with ratios and fractions and things of that nature, adding and subtracting are not our best ways of figuring out what the relationship is between the two. So I can look at the other relation. I can say 4 times 5 gives me 20. So then I can look and say, okay, well, if I have 5 pizzas, I know I need to multiply by 5, and that's going to give me 25. Does that follow the pattern down here? We're going up by 5 every time. It does, so I know that I've found the correct pattern. So now what I need to do is I need to do the opposite here, and I need to divide by 5, and in this case, this is going to give me 6. And then again here, I divide by 5, and it's going to give me 3. So the ratios of pizza to cost is 3 to 15, 4 to 20, 5 to 25, and 6 to 30. Now, you don't have to have all of this mess in here, because I know it gets a little confusing. You can just fill out the table, but you need to know how to go from top to bottom and bottom to top to find your answers. All right, and the next thing we're going to talk about is drawing a model of a ratio. So you don't always have to look at it in your head. Sometimes it's easier to draw it out, and I know some of us are very skilled artists, however I'm not, so I like to just use my counters. So I look at the problem. I have Daniel is growing tulips and daffodils in a pot. For every 3 tulips he plants 1 daffodil. So to draw a model of that, I would have to say, or know that, all right, I'm going to use red for tulips, and I'm going to use yellow for daffodils. And if you just want to write red and yellow, that's okay as well. And then what I'm going to do is I'm going to represent the number of tulips. So for every 3 tulips, 1, 2, 3, I have 1 daffodil. So here's a model of my ratio. I know my ratio is 3 tulips to 1 daffodil, and here's a model of it. Right, now, to use that model, what I can do is I can look and see how many daffodils will he plant if he plants 12 tulips. So what I can do is I can draw my model again. So I know I have 3 to 1. So I have 3 tulips, and I've planted 1 daffodil. And I can do it again. I can plant another 3 tulips, which means I've planted 1 daffodil. So I have 6 tulips, 2 daffodils. And we need to be able to draw these models. So I know that there's a different way to do this just using math, but right now we're focusing on how to use models to find our answer. So I have another 3 tulips, which means I get to add another daffodil. I'm at 9 tulips, 10, 11, 12, which means I get to plant 1 more daffodil. So if I plant 12 tulips, I know that I have to plant 4 daffodils. All right, so what I'd like you to do for tomorrow, I would like you to fill in the answers for these different problems. For the first one, I just want you to use this chart and write the ratio for each of the different problems we have here. So cats to rabbits, dogs to total number of pets, and total number of pets to cats. And then here you're going to draw a model and then solve the problem. So it's 2 steps. One, you have to draw a model, then you have to continue to draw models to find your answers. And then down here, I want you to complete the table. As always, if you have any questions, please be sure to post them to Edmodo so we can go over them in class.